This next series of lessons here, they're going to be real quick and short, hopefully, and cover some basic ideas, but they'll be good to be able to come back and reference as time goes on. So this first one that we're going to look at is data collection. So when we talk about data collection, we're talking about observations. And observations are something that are objectively sensed or measured. And so there's two kinds of sensing that we can do, or measuring that we can do. We can do qualitative observations, which are non-numerical, and then quantitative observations, which are numerical. So an example of a qualitative observation would be saying the sky is blue. An example of the quantitative observation would be the desk is 30 centimeters wide. So you can see that if you can put a number to it, it becomes quantitative. If you're describing it, it's qualitative. Both have their purpose. Neither is better. It's just knowing that we have those two things. So to go back to it, if you're talking about, say, two cars that are traveling, and you only want to describe car one, you can see where we might want to know both of these observations, where we might say car one is traveling at 30 meters per second, or we might say car one is traveling faster than car two. Both of those are useful because they convey different things about the situation. The second thing that we're going to talk about with data collection is inferences. And inferences are an assumption about a phenomenon. So that's basically an explanation. And these are typically based on past experience or about understanding, but it is important to distinguish these from observations. They're not the same thing. An example of something that you might think is an observation, but is actually an inference. If you're looking at, out on the playground, you dump some water on the ground and you watch it for a while and you see that it disappears. If you said the water evaporated, that would be an inference because you didn't see the water evaporate. There was nothing, that's not something you can directly observe. Now, what you would say if you wanted to make an observation would be the dark spot on the asphalt got smaller and smaller and smaller in area, and eventually there was no dark spot. That would be the observation. The inference that you're drawing from past experience is that water will evaporate when it's on the ground, especially if it's warm outside. And so this is why we want to distinguish these two, because typically, if there's going to be a mistake, it'll be from an inference. You can make mistakes in observations, you can make mistakes in your measurements, but more often than not, if there's an issue, it's because you're inferring something that happened rather than just recording exactly what happened. The last thing we want to talk about with measurements are accuracy and precision. And you want to be aware of both. And the difference between them is accuracy is how close to the proper or expected value. And precision is how similar multiple measurements are. So you'll sometimes see the example of like a bullseye. So if this is my bullseye, these, I shoot a bunch of arrows, all of those dots would be precise, but not accurate. Because they're all quite close together, but they're not close to the bullseye. This would be precise and accurate. And then technically, we can sometimes talk about something that's accurate but not precise. That might look something like this, where it's all centered around the bullseye, but they're not grouped tightly. But we don't typically talk about that last situation. We usually only talk about whether it's precise or not, and then if it is precise, we'll talk about whether it's accurate or not. And the reason for this is because we don't always know the proper value. So we can't know if my results are accurate, just not precise. We can only know whether they're precise or not, and then from taking a bunch of measurements over time, having some other people do it, then we can figure out, okay, yes, this probably is also accurate.